Welcome to the Plano Green Team oral presentation. With the current status of our team, we don't have a fully built car yet, but we are still working very hard and diligently on the different parts of the car, and we will be explaining our engineering decisions and processes throughout this video. To start, when our team members first came together, we actually had the previous team's car built. With our first big decision, we decided that we were going to use the old car as an example and build our own car.
So now that we have established that we have decided to make a new car, we had a lot of design requirements that needed to be worked on from the ground up. So let's start talking a little bit about the overall aspect of our car.
Being completely new to CAD, it took me a couple weeks to really begin picking up the pace. Within the first month, I was able to CAD out my first design of the car, and after over 100 different versions and shapes, I was able to create a full frame and shell. As you can see, the shell frame triples as the cornerstone of the car, a support for the solar panel array, and easy outlines to cut and place geometric coroplast panels to create the outer shell. Being new to the solar car world was one problem. However, being unfamiliar with the topic of aerodynamics, 3D CAD modeling, and wind tunnel software was one of the largest hurdles I've ever had to overcome during this project. After doing extensive research, I was able to CAD out different models of what I wanted the car to look like, as well as put it into a virtual wind tunnel, giving me the total air resistance in newtons, as well as visuals for eddies and turbulence. This also helped me realize the need for an aerodynamic nose cone. After multiple iterations of testing shapes of nose cones, I found the one that comes to a vertical and horizontal point to be the most effective. When brainstorming, constructing, and executing the design of the car, I decided I wanted the wheels to be enclosed within the shell. I wanted to ergonomically fit the major components of the car in a reasonable place within the shape of the shell, and I wanted the shape of the car to be as aero as possible, and overall I wanted the car to be as cheap and easy to build for the sake of beginning team. Therefore, with taking all those into account, I was able to CAD out multiple iterations, ultimately leading to the teardrop shape as seen in the picture.
The previous car was actually really heavy, and of course that affects performance. So as we're building our new car, something that we're always looking for as we're buying materials is whether or not they're lightweight or not, because every single part contributes to the weight of the entire car.
So we wanted to make sure that our car had an equal weight distribution on the front wheels and the back wheel. So how we did this was we first created a spreadsheet calculator that took in inputs, and these inputs were how far away each component in the car, such as the seat, the motor, and the batteries were from the front of the vehicle, and how much they weighed, because these are the two components that affect weight distribution. And using these inputs, the calculator would output how much weight was being put on the front wheel and being put on the back wheel. So using these numbers, we came to the conclusion that our car didn't have an equal weight distribution. So in order to rectify that, we had to go through multiple iterations where we took a specific component in the car and moved it closer or farther away from the front of the vehicle. And we saw how that changed the weight distribution and if it made it more favorable or made it more unfavorable. And going through these multiple iterations, we finally came up with our most optimal design, which is the design we have today, by moving the seat closer to the front of the car and moving the motor and the batteries closer to the back of the car to get a relatively equal weight distribution.
So now that we have discussed the overall arching theme of our car, what we want in our car, let's start talking a little bit about some of the specific parts that we've worked on, and let's delve deeper into each of those. So one of the main parts that we've been able to work on during the quarantine was our roll bar.
So with the roll bar, I was actually able to coordinate with Metal Supermarkets and Pronto Mufflers and Brakes to have our roll bar bent. And this was really difficult for us because we weren't sure if we were going to be able to bend it to our specifications and how we planned for it to fit in our car. And it was also really difficult because we were trying to do this during quarantine, and we weren't sure if any of the shops were actually going to be able to open and help us. But it all worked out, and now we have our roll bar bent.
Working on the roll bar was one of my first projects that really had value to me. Being able to CAD out a roll bar, as well as see the final results of what I did within a month, was both super exciting but terribly suspenseful. Having to take into consideration the height, width, shape, weight, thickness, and type of metal was very stressful, but that was only one hurdle in the thousands yet to come.
Next up, let's talk about our steering wheel.
So for the steering wheel, we really wanted to custom make our own steering wheel that fit our car and our team. This was also a great opportunity for us to really work together on a project since quarantine started, and we haven't really been able to work together on a project because we're all new to the Solar Car Challenge, so we haven't had that opportunity before. Also, something that made it difficult was that we're an independent team, so we're not tied to any school or any school district. And that means we don't have any resources from the school. And it can be difficult at times, but we can still work together, and I've been managing and kind of planning out all of our calls and everything, and we've been able to still do a lot even without help from the school, and that includes designing and building our own steering wheel.
For our steering wheel, we decided to customize a completely new one because our old steering wheel was outdated. With this new customized steering wheel, we started the design process of brainstorming multiple ideas. This is the final design of our steering wheel. The grip is split up into multiple pieces so that the parts can be easy to manufacture and that they're also customizable. I calculated the stress on the center to figure out which material was the best for the rigid part of the steering wheel, which is right here. We decided to use 6.3mm mild steel to be the rigid part.
Something really unique about our team is that we aren't connected through a school, which means that we have no support in terms of finance or in resources. But on the plus side, we get to be independent. As well as this, all of our team members are new to the solar car world, so we've come so far from where we first started, and we are really excited to move forward with our car. We hope that these circumstances will allow all of us to meet in the 2021 solar car race. Good luck, teams!